Let's practice assigning oxidation numbers. Remember, long term, what we need to get is the oxidation number on the individual atom. That's going to help us with future analysis and future problems. So I'm going to circle the oxidation number on the individual atom to kind of demarcate it or separate it from everything else that's going on. So let's split this in half. I'm going to assign an oxidation number of -2 to the oxygen. There's 3 oxygens, so 3 times -2 gives me a -6. This is a neutral molecule. It didn't have a charge on the outside when I started, so everything has to sum up to 0. So since this side has a -6, I'm going to do a +6. On the other side, there's 2 nitrogens, and they share that +6 charge, or oxidation number. So individually, they're both going to be +3. On letter B, this is our first rule. If there's something, a monoatomic element, a diatomic element, anything that's composed of a single element, it's automatically going to have an oxidation number of 0. Over here on the carbon monoxide, I'm going to do a -2 on my oxygen. Since it's a neutral compound, that means the carbon has to be a +2. So here we have an ion that's composed of a single element. Therefore, the oxidation number is going to equal to the charge on that ion. We'll do a -1. For methane, or CH4, it's important to remember that the carbon is a little bit more electronegative than hydrogen. Hydrogen has 3 possibilities for its oxidation number. It can do a +1, it can lose its only electron, it can gain an electron and do a -1, or if it's hydrogen gas, we'll see hydrogen having an oxidation number of 0. So here, since carbon's more electronegative, carbon is going to pull those electrons away from hydrogen. Carbon's going to steal the electrons, in theory, right? Remember, oxidation numbers are theoretical. So I'm going to do a +1, since hydrogen is going to be the loser. I'm going to do a +1 on the hydrogen. +1 times 4 gives me a +4. This is a neutral compound. It needs to add up to 0, so I'll do a -4 on the other side. And that entire oxidation number of a -4 belongs to the single carbon. On letter F, there's 3 elements in this compound. So I'll start with the oxygen, since I'm pretty confident that that's going to be a -2. There's 4 oxygens, so -2 times 4 gives me a -8. Unlike the previous examples, now we have a charge. This is one of our polyatomic ions, hydrogen sulfate. It has a -1 charge. So everything going on up top has to equal -1. I don't know what sulfur is going to do. Sulfur's kind of in the middle, and it could do different oxidation numbers depending on the situation. However, my prediction is going to be that hydrogen is going to be a loser, especially when it's going up against sulfur and oxygen, which are extremely electronegative compared to hydrogen. So I'm going to do +1 on my hydrogen. There's only 1 of them, so I'll get a +1 on top. So now I have +1 minus 8 equals -1. What number can I put in there to make that like a true algebraic statement? Well, if I do a +6, now I have +7 minus 8 equals -1, and that's true algebraically. So that means sulfur has an oxidation number of +6 in the hydrogen sulfate. Whenever you're trying to assign oxidation numbers to a compound that has parentheses, my recommendation would be to first split it up into its ions as best as you can. So we know this comes from magnesium 2+. Since magnesium is in group 2A of the periodic table, we know its charge. And then if we look on our table of polyatomic ions, we're going to recognize this as hydroxide. So before somebody did the crisscross to come up with the formula of this compound, they had magnesium 2+ and hydroxide with a -1. So you're undoing the crisscross, splitting it up. Now I can safely assign a oxidation number of +2 to my magnesium. And then I'm going to split this up, the hydroxide, I'm going to split into 2 pieces. And I'm going to do a -2 on the oxygen. And since everything within the hydroxide has to equal -1, right? It's got a -1 charge. I'm going to do a +1 on my hydrogen. -2 + 1 is going to give me my -1 charge. Next we have sulfite. So let's just split it into 2 pieces. -2 on my oxygen. -2 times 3 is -6. It has to add up to a -2. So I'm going to have to do a +4 on my sulfur. +4 minus 6 gives me the -2 that I need. And then the last one is a standalone ion, one thing. So the oxidation number will be the same as the charge. For our diatomic elements, they're always going to have oxidation numbers of 0. On the next example, I'm going to do a +1 on my potassium. And I'll do a -2 on the individual oxygens. -2 times 4 gives me a -8. This is a neutral compound. Everything has to add up to 0. So I'm going to do a +7 on the manganese. +1 + 7 minus 8 equals 0. Letter L is a super challenging example. Mercury is such a weird ion. We need to be able to figure out, before we assign the oxidation numbers, did they combine mercury 1 with nitrate or mercury 2 with nitrate? In my opinion, the most straightforward way to go about figuring out what happened is to redo the crisscrosses with both possibilities and see which one is the best match. So with mercury 2, I would put a parenthesis around the Hg subscript 2. Remember, that's a polyatomic ion. And put a set of parentheses around the nitrate. So then the 2 would go to the outside of the nitrate, and then there'd be a 1 that would go down by the mercury. So I'd wind up with Hg2 with a 1 outside the parentheses, and then the nitrate would have a 2 outside the parentheses. We can get rid of the parentheses when there's a 1 involved. So we'll do Hg2 and then NO3 2. And that looks like it's a match. So this is mercury 1 nitrate. If we go ahead and do the crisscross with the mercury 2 nitrate, we get Hg parentheses NO3 2. So it's definitely not mercury 2. We're looking at mercury 1. So to assign the oxidation numbers, I'm going to do Hg2, 2+, and nitrate, NO3-. So you may have been wondering, why is mercury with a subscript of 2 and a charge of 2+, why is that known as mercury 1? Well, here's your answer. We have 2 mercuries, and they're sharing that +2 charge. So individually, they each have oxidation numbers of +1. +1 times 2 is going to give me my +2. Over here, for nitrate, we'll do a -2 with the oxygen. -2 times 3 is -6. It has to add up to a -1 altogether, so I'm going to do a +5 on that nitrogen. So +5 minus 6 equals -1.